Let's evaluate the cosine of the sine inverse of 12/13 and give an exact value answer. So let me write that down. That was written a little funny there. So it's the cosine of the sine inverse of 12/13. Cosine of the sine inverse of 12/13. How do we do this? Well, notice this is a mix of trig functions, right? It's a composition. It's composed, like two trig functions composed together. One's a regular trig function, one's an inverse, and they're different. One's cosine, one's sine. So it's a mix of different trig functions where one's an inverse and the other's not. Let's go back to the notes. So this is in the notes. So this section is composition of the same inverse and regular. That's not what we have. That'd be like sine inverse and sine. Those are the same trig function. One's an inverse, one's a regular. We're talking about this right here, the composition of different inverse and regular, like cosine of tan inverse or something like that, right? We're mixing different trig functions with a composition of an inverse and a regular. So how do we do it? How do we handle it? Well, what we do is step one, we start on the inside. So that part that's on the inside, you start with that. Tan inverse, set the inside tan inverse equal to A, where A is some angle. We can say the same equality the other way. So tan inverse of negative 14/9 is A, means tangent of A is 14/9. And then you draw a triangle showing that truth, remembering SOHCAHTOA, the tangent of A, 14/9, opposite over adjacent. And then you do the Pythag, and then you do that. So let me show you that. Let's go through the steps here. So step number one, take the inside, which is sine inverse 12/13, and set it equal to A, where A is an angle. Remember how that works? For a normal sine function, we plug in an angle, right? And we get out an answer. For an inverse sine function, or cosine or tangent, it's all the same thing, you plug in an answer. You reverse it, right? And get out an angle. That's what's happening here. This must be an answer, and this must be an angle, because it's sine inverse. So that means that the sine, regular sine of that angle A, in fact, let me just write it down here because it's important. It means that the regular sine, see how I went from sine inverse to regular sine of that angle, you can just swap them back, in other words, and make it normal sine. So do you see what I did there? So a sine inverse statement implies the reverse sine statement, of course. That's what an inverse function does. It swaps these. So we can go from the inverse function back to the regular sine function and swap these guys back, right? If the sine inverse of 12/13 is A, then the sine of A is 12/13. Just swap them back. It's the very meaning of an inverse function. Okay, so now what do? Step two, or maybe this is still step one. I forget how the steps go. We're going to make a triangle next. That much I do know. Let's make a triangle next. So I'm going to come here and make a right triangle. Little right angle right there. So I'm going to make a triangle, and I'm going to put A here. Here, let me just go back with the blue. So you can put it anywhere you want. Oh, thought I got rid of that. There we go. Put angle here. You can put it up there. It doesn't matter. Okay, and sine of A is 12/13. Now remember SOHCAHTOA. Remember the definitions of sine, cosine, and tangent. Sine is what? So means opposite over hypotenuse. So this side is the opposite. At least if you put A in the lower right corner, this is the opposite. This is the hypotenuse, of course, because why is this the hypotenuse? Because it's across from the right angle. And then this side must be the adjacent because it's next to A. That's what adjacent means, like your neighbor lives adjacent to you, next to you. Okay, so what's sine? It's opposite over hypotenuse. Opposite over hypotenuse. So the 12 must be the opposite. The hypotenuse must be 13. So we can use that now to find the adjacent. Call this, A or B or X or whatever you want. So then step 2 is use the formula a squared plus b squared is c squared, the Pythagorean theorem. So we go a squared plus 12 squared is 13. So remember, the hypotenuse has to be the c, because that's the longest side. A squared and b squared add up to be c squared. He's the longest side. The hypotenuse is always the longest side in a right triangle. So there we go. Let's solve for a. 144, 169. Let's subtract 144 here. And boom. And we have a squared is 25. Root it. So that a is 5. So we can bring back this side must be 5. A is 5. So now we can use our triangle. Step 3 is, I think it says finish the outside. Let me just show you. So step 1, we drew the triangle using SOHCAHTOA. Boom. Step 2, find the third side by the Pythag. We did that. Step 3, find the trig function on the outside. Now go back to the outside and finish it up. All right, let's do it. So now finish the outside. So what is the outside? What was the original question? Well, I lost it. There it is. Here's the original question. Bring down the original. It was cosine of sine inverse of 12/13. But we already said sine inverse of 12/13, that's A. So this inside right here, all of this is A. That's kind of ugly. Let me do it this way. There. That's all A. Right here. Sine inverse of 12/13 is A. And we put A in our triangle. So this is cosine of A, isn't it? And we can find cosine of A because we've got it in this triangle. What's cosine? Cosine is SOHCAHTOA, adjacent over hypotenuse. So this is going to be adjacent over hypotenuse. Adjacent, 5, over hypotenuse, 13. And there we go. We were able to do a mix of a regular and an inverse trig function. Didn't even need a calculator for any of that, right? We were able to do a mix of a regular and an inverse trig function with different trig functions. How did we do it? We started on the inside, and we just said, well, it's equal to some angle, because you plug answers into inverse trig functions, get at angles, and then that we swapped it back to the regular trig function, because that's what an inverse function is an inverting of those. We went back to the regular trig function. Well, then the sine of A must be 12/13, and then we put that in the triangle. The sine of A, opposite over hypotenuse using SOHCAHTOA, 12/13, and then we found the other side, the 5, using the Pythag, a squared plus b squared is c squared. And then when we did that, went back and finished the outside question, remembering it was cosine of sine inverse, and the whole sine inverse on the inside, that was just A. So it's cosine of A, and we can find cosine of A from the triangle based on the SOHCAHTOA definition, adjacent over hypotenuse. Adjacent over hypotenuse. There we go.